So apparently I didn't send the right presentation, but let's go. So I'm not going to talk about Delft-FEWS. So I only had 5 minutes, so I had to pick what to talk about. The only thing I would like to mention here that the software, everything you'll see here, it's the software that we developed and it's free of charge. I also want to talk about how we implemented it in 63 countries, over 200 systems and whole investments that you can exchange over different data formats, that you can integrate real-time data, assimilate data, raising curve integration, analyze historical flood peaks in the system, analyze the performance of your forecast, or use scenario analysis. Yeah, a lot of different models integrated. We have a long-term archive and a whole community of practitioners that use the software. We have around 20 consultants that know how to implement and build these systems. But what I actually want to talk about in these 5 minutes is interactive forecasting, as we call it. So instead of using a global approach, we always try to start with a local, trying and build this early warning system local, starting with local procedures and local actions to integrate this into the system. So one of the projects where we did this is the Incident Management Forecasting System, IMFS. So it's the national flood forecasting system in the UK. With around 600 hydrological models integrated, 20,000 local impact thresholds. So it's really at local locations, determining the impact with around 40 daily users. During flood events, this goes up to 100, and an online dashboard where warnings are disseminated. So just really simply how it works, there are 3 flood categories, a flood alert, a flood warning, or a severe flood warning. These are sent out to the public, so you get a push notification on your mobile phone when flooding is happening. So in the UK, there are 6 centers, each divided among 12 areas. And this is an example of what these operational rooms look like. So this is where the flood forecasters are sitting and producing daily flood forecasts. And what's interesting is that there's a whole group of people that are actively working on producing flood warnings. So you'll have from the UK Met Office, the forecaster who produce the weather forecast. You'll have a hydrometeorologist that combines this information to a flood forecast. You'll have monitoring forecasting duty officers who produce local catchment flood forecasts. And then they call it photos. It's not from the Lord of the Rings, but it's the intelligence and reporting cell. So they are responsible for the response when a flood is happening. So they work with 2 or 3 scenarios. The first are a best estimate and a reasonable worst case scenario for like the longer term outlook. And then the MFDO has an operational flood forecast for the first 2 days, really for the response activities. So how does this look like in FEWS? So in FEWS, what we implement are kind of like ways for a forecaster to interact with the early warning system. So the concept behind it is that in your warning that you're disseminating, there's always some kind of uncertainty, right? So you send out you have your flood forecast, and there's always a little bit of uncertainty around the timing of the flood peak, the height of the flood peak. So the way that we work is by using local knowledge by the hydrometeorologists in the system to produce a better flood forecast. So one way is with a meteorologist, they can create kind of like weather scenarios. They can select an ensemble member from 50 different ensembles and then select the one that they believe is the most likely considering their knowledge of the weather system. The other one is on real-time modeling. So in this case, you'll have a hydrologist who knows something about the catchment, for example, how does catchment responds to certain type of rainfall events. So they can adjust, for example, the rainfall depth, the amount of rainfall, or change the catchment state. So if there's a lot of snow, change the snow state, change the temperature, or change the rainfall. So it's really this kind of like modeling to improve the forecast. So in terms of flood warning dissemination, the important part here is that you reach the right communities, that flood warnings are not sent out on a national level, but really sent to local citizens living in a certain neighborhood. So the way that they work is they have these kind of flood warning areas, and these are kind of like areas with a similar impact. So for each of these areas, they defined a number of thresholds. So they can be alerts where people are made aware of a flood is happening, or really a warning where houses are flooded. It also includes thresholds where you can say, okay, we now need to put down temporary defenses to protect people against flooding. So this is what it looks like in the system. And then in total, there are over 20,000 of these kind of impact thresholds integrated in the system. Another thing that is in there is also kind of like historical flood events. So sometimes when you communicate a flooding, when you talk about we expect a 3-meter flood, people living in a neighborhood, they won't know what that means. But if you say, well, it's a flooding as bad as the year 2000 or 2004, they will remember, because historically that's still imprinted in their minds. So this was a really short introduction. So if you want to know more about Delft-FEWS or this kind of interactive forecasting, please let me know.